Design guidelines play a key role at early stage of building design to take into consideration the main climate-responsive strategies for sustainable buildings. In this lesson, we will provide a set of guidelines for sustainable buildings according to different climatic zones. The main topics covered are design strategies for the site planning, considering especially sun protection and ventilation, design strategies for building plan, considering sun protection, ventilation, structure as roof, wall and ceiling, and windows or ventilation openings. Let's start with hot, humid climates. Because of the temperature and the humidity, the most that can be done is to keep indoor comfort conditions similar to those outside in the shade. To achieve this, three main provisions should be made: protect from solar radiation, maximize ventilation, and use of the humidification systems. In order to provide sun protection, the building should be surrounded by trees, shrubs, and grass, which will absorb solar radiation, not reflecting it into the building. Trees need to be with high trunk and appropriately positioned to avoid screening of the wind. Natural ventilation should be exploited as far as possible, so sites exposed to prevailing breeze are highly desirable. The closer the sea and the higher the ground, the more the breezes. In the building plan, it is pivotal to ensure suitable sun protection. For this reason, windows should be provided with shading devices. Furthermore, buildings should preferably be oriented with a long axis running east-west to provide easy, effective shading and minimize east and west facing openings in order to reduce early morning and late afternoon heat gain. Also, natural ventilation should be properly addressed, since after sun shading it is the most important element affecting comfort. Cross ventilation, in this sense, represents a very effective solution. In order to enhance ventilation, buildings should be more than 1 story high, preferably with the ground floor left open or used for non-living purposes. And now some suggestions regarding specific building elements. For example, regarding the roof, it has to be said that an important feature is to protect walls, openings and interior from direct sunlight, particularly on east and west walls. The roof should be made of lightweight materials with low thermal capacity and high reflectivity, and should be ventilated or well insulated to reduce the heat gain due to solar radiation. If the roof is not insulated, a ceiling is needed and the space between roof and ceiling should be ventilated for reducing thermal discomfort. It is even better if the ceiling is also insulated. The walls should have a low thermal capacity. Sun protection is very important and can be achieved by orienting east-west the long axis of the building, shading with overhangs, verandas or other devices, or shading with trees. Now let's move to hot, arid and semi-arid climates. Because of the high daily temperatures variation, it is best to keep the heat out during the day and to ventilate during the night. To achieve this, 4 main provisions should be made: protection from solar radiation, use of high-medium thermal mass for walls and roof, use of operable windows, and use of sustainable cooling systems such as evaporative cooling. Housing layouts should be in compact urban form. Compact planning minimizes the solar exposure of individual houses and reduces also solar heat gain by providing mutual shading and by reducing external surface areas. Buildings should be compact, but allowing good natural night ventilation, and should be oriented with the long axis running, where possible, east-west to provide effective shading. Regarding the building elements, note that roofs should be preferably made of heavyweight materials and high reflectivity coatings and should be ventilated. Alternatively, if the roof is lightweight, the ceiling should be heavyweight and the attic ventilated. Heavyweight walls are climatically well suited for this zone. Brick or soil cement walls should not be less than 30 centimeters. The thicker, the better. For windows and ventilation openings, solar protection is, of course, recommended. A good solution consists in the use of shading systems that also allow natural ventilation. In this regard, it should be noted that adequate night ventilation helps to prevent overheating. An effective mitigation strategy in this climate is represented by evaporative cooling. The cold arid and semi-arid climates are present in a very limited area of Africa. Because of the low temperatures, passive heating is welcome during the cold period. To achieve this, three main provisions should be made: protection from solar radiation in the hot period and some openness to sun during the cold season, use of medium high thermal mass for walls and roof, use of sustainable heating system such as heat pump or biomass stoves. Generally, in such climates, building sites should be so selected as to provide shelter against prevailing winds and cold air pockets in ground depression. Buildings should have their main glazed elevations oriented north-south, also northeast-southwest orientation is appropriate. With carefully calculated sun shading, this orientation will allow a certain amount of solar heat to penetrate during the cold season in the early morning and to cut off low west sun in the afternoon. Roofs can be light or heavy, but they must have a good insulation value. Medium weight walls, floors, and ceilings are recommended for the best exploitation of solar passive gains. Regarding windows and ventilation openings, devices for sun control are necessary in order to keep out the sun during certain hours of the day. Note that they should be also adjustable to let sun in when it is required. Large windows facing east or west should be avoided due to the risk of overheating for greenhouse effect and the related need to ventilate using the excessively cold air from outside. In such zone, sustainable heating systems such as vapor compression heat pumps should be provided to ensure comfortable indoor temperatures. And now let's speak about temperate climate. With conflicting seasonal requirements, heating and cooling demand should be considered together. To achieve this, three main provisions should be made: protection from solar radiation in the hot period and some openness to sun during the cool period, use of medium thermal mass for walls and roof, provision of sustainable heating systems. In general, buildings in temperate climates can be arranged rather freely. Settlements should be semi-compact to provide mutual shelter from sun in hot season, but also wind protection in the colder one. In this zone, buildings should be preferably compact. The orientation of the building highly affects its energy demand, thus it should be carefully considered. In general, buildings should have an elongated shape along the east-west axis. The construction of roof should be characterized by medium heat storage capacity to balance temperature swings between the daytime and the evening hours. The mass should be placed in the inner part of the construction. The average area of the openings should be about 30% of the area of north and south facing walls to ensure sufficient ventilation for comfort and for cooling the structure at night. Preferably, openings can be placed mainly above the staircase or overhangs. In general, shutter, screens and pergolas that allow ventilation, lighting and views and simultaneously control the penetration of the sun in the summer period should be considered. Deciduous trees are also suitable for shading purposes. In conclusion, designers should be aware about the various strategies to apply in buildings in different climates.